In this video, we're going to see how a basic image created in Blender can be used to control AI image generation, turning this into this. The trouble with using text to image is that it is almost impossible to convey exactly what we're after in terms of positioning objects and camera angle. But by creating a very basic layout in a 3D package such as Blender, we have a more precise way of letting the AI know what we are after. Of course, at least a basic knowledge of Blender would be useful. Blender is a free but professional-level 3D modeling package, and you can download it from the address given below. As you'll see in a moment, the type of scenes we have to create are so simple that even if you have never used Blender or any other 3D package, you'll know enough within 5 minutes to create the scenes used here. When we first start up Blender, we'll see the app layout and a central splash screen. Clicking outside the splash screen will make it disappear, and we are left with the main layout. The largest area here is the 3D viewport. By default, there is a cube, a camera, and a light. If we click on the cube and press the Delete key, we are left with the camera and light which we need to retain. But we can hide them from view by unchecking Extras in the Viewport Overlays panel. Now we want to add the elements of our scene. In the Add menu, we select Mesh and are given a choice of basic shapes we can place within our scene. We'll choose UV Sphere. Next, we'll add a cube. The cube is placed in the exact same position as the sphere and is about the same size. By pressing S, then moving the mouse, we can resize the cube. Then, pressing G, we can move the small cube away from the sphere. Just one final menu option adds smoothness to our sphere's surface. That's our first scene setup. Now we must create a picture from our scene, or, as it's called in 3D parlance, a render. To do this, we need to select Render in the main menu, and then Render Image. The first thing we'll notice is that the rendered image uses a different viewpoint from that shown in the 3D viewport. This is because the render uses the view from the camera that we hid earlier, and the 3D viewport has its own independent viewpoint. If we press 0 in the numpad part of the keyboard, the 3D viewport will show the view from the render camera. The part that will actually appear in the render is indicated by the lighter rectangle at the center. By pressing N, a panel known as the sidebar will slide into place. This has 4 pages of information. On the View page, there is a checkbox labeled Camera to View. By selecting this box, we can rotate the viewpoint around by dragging with the middle mouse button pressed down. We can also move the view up, down, left, or right by also holding down the Shift key. When we get the view we want, we can again select Render and Render Image. And the final step is to save the rendered image. There's no need to save the Blender scene itself, since we won't be using it again. Stage 2 of the operation is to go to our AI image generator. Personally, I have accounts with Kling, Dreamina, and 11 Labs. Each of these allows us to use one or more text-to-image generators. We'll start with Kling. After choosing Image Generation, we need to upload our Blender-generated image and provide a description of what type of scene we want generated. After waiting a couple of minutes, we get this. Using the Blender image and same description in Dreamina, we get these images when using GPT Image 2. and these when using Image 5.0 Pro. For the second example, we are going to create a moonscape with a SpaceX Starship sitting on the surface. To begin, we'll select the existing sphere by clicking on it, and by holding down Shift and clicking on the cube, both items are selected. Next, we'll press the Delete key to remove both objects from our scene. The first item in our new scene is a grid mesh, in the bottom left of the 3D Viewport Last Op panel. When we expand this, we'll see a few values that relate to our newly formed grid. We'll change the fields labeled X subdivisions and Y subdivisions to read 200. Using the mouse wheel, we can zoom in on the grid, and by pressing the Tab key, we enter something called Edit Mode. In this mode, we can see the basic elements that make up every mesh. These elements are vertices, which show up as dots, edges, which show as straight lines, and faces, the individual filled-in areas. Near the top left of the viewport are 3 buttons. These determine which type of element, vertices, edges, or faces, we want to manipulate. By default, it's vertices, but if we click on the second button, we change to edges. We'll return to vertices. If we click on a single vertex to select it, and then press G followed by Z, dragging the mouse will move that single vertex upwards, that is, in the Z-axis direction. We'll press Ctrl-Z to undo the move. In the top middle of the viewport is the Proportional Editing button. When we switch on this option, then move our vertex for a second time, the surrounding vertices also move, but to a lesser extent. The area over which this effect operates depends on what's called the circle of influence. Normally, the circle is invisible, but if we roll the mouse wheel during our drag operation, the circle not only becomes visible, but also changes in diameter as we roll the mouse wheel. Using the GZ combination and varying circle sizes, we can manipulate the contours of the grid. Pressing Tab exits Edit Mode. Next, we'll add a cylinder mesh. Scale it down by pressing S and dragging. Then we'll increase its height by pressing SZ and dragging. This represents the position of the spacecraft. You may notice that part of the cylinder is under the grid mesh, but we don't need to worry about that since it won't show up in the render. Next, we need to press 0 on the numpad to see the view from the render camera. Then, using mouse wheel rolling to change the zoom factor, dragging with the mouse wheel down to rotate the view, and holding the Shift key and dragging with the mouse wheel down to move horizontally or vertically, we'll arrive at a view we are happy with. Now we render and save the image file. When we use our rendered image in Kling Omni with this description, the results are disappointing. The first generated image doesn't use the layout of the Blender image, and the second attempt retains part of the Blender image unchanged. However, when we use DreamNR's Image Pro 5.0, the generated images match the Blender image layout and viewpoint exactly. It even manages to give a passing resemblance to the Starship. For our final example, we are going to create a bedroom scene with examples of both modern and Victorian styles. Starting with an empty scene, we'll add a cube and scale it up by pressing S and dragging. Changing to Edit Mode by pressing the Tab key, we'll choose Face Selection. Select 3 of the cube's faces and delete them by pressing the Delete key. The remaining sides will act as walls and floor of our room. After leaving edit mode by pressing Tab for a second time, we'll select the Add Object tool from the toolbar panel. This allows us to easily add shapes to existing surfaces. There are several shapes to choose from. We'll start with a cube. As we move the mouse pointer over the remaining faces in our scene, you'll see a grid pattern which has the same orientation as the face it is currently over. By clicking and dragging, we define the base of the cube we are about to create on the existing surface. Once we have the correct base shape, we need to release the mouse button. Now when we move the mouse, we are defining the third dimension of our cube. Clicking finishes the operation, and Blender adds our completed new shape, which should really be called a cuboid rather than a cube, since not all sides are the same size. This will be the wardrobe in our room. Next, we define a second cuboid to be the bed, another to be the bedside table, and a final one to be a bookshelf. Now we'll swap over to a cone shape and place it on our bedside table to be transformed later into a lamp. And the last item is a cylinder, which we'll place on the top of the bookshelf. This will become a clock. To see the view from the render camera, we'll press 0 on the numpad and zoom, rotate, and move until we get a viewpoint we are happy with. When we render the scene, there's a lot of shadow. This is because the light in the scene is being blocked by one of our walls. To fix this, we need to select the light by clicking on it, then pressing G and dragging until it's within the room. Now when we render the scene, we get much better lighting. Finally, we save the image in our folder. Since Dreamina's Image 5.0 Pro seems to give the best results, we'll make use of it for our generated images. After uploading the image, we'll use this as the description of the scene we want to create. Here are the results. Now we'll give the AI a slightly freer rein by adding these two sentences to our prompt. And the results we get are quite impressive, although it has moved a few elements. This video combines my interest in Blender and AI image and video generation, and I intend to add more videos in this area over the next few months. If you would like a much more in-depth tutorial on Blender, you can follow my other videos on this channel.